Hello everyone, welcome to Math with Mr. Fitri. This will be our first math class, and like our science classes, we are going to focus on some critical vocabulary. This is vocabulary that we will be using this term, some next term, and which I'm sure you will use both in science and math, maybe even in your future English classes as well. Please, if you would, follow along with the worksheet, all right? It provides an area for definitions and for examples or formulas. So we will start with some basic information, the basics. All right, everyone, we will begin here with unit. A unit is the standard unit used to measure. Some examples include centimeter, meter, kilometer, liter, ounce, etc. And we see these every day, right? Driving down the road, we see speed limit signs. If we go into a store, we see ounces or liters on bottles. Okay. Now, I will keep moving through these vocab words. So if you need to pause to write the information down, please do. Next, an exponent. An exponent refers to the number of times a number is multiplied by itself. So what do you mean by that? Well, surely we've seen these before. All right, we've got our base number 4 and our exponent 2. So what does this look like? Well, it looks like this. 4 squared, or 4 to the second power, is simply 4 times 4, and that equals 16. It is a number that is multiplied by itself. Here we have 3 to the 4th power. Again, this is simply 3 times 3 times 3 times 3. Here we're getting into very large numbers now, but 5 to the 5th power, 5 times 5 times 5 times 5 times 5 equals 3,125. Now, exponents could be massive numbers if need be. Maybe 9 to the 20th power, 7 to the 15th power. Okay. For our class, though, when and if we use these, it will be more simple, okay? So don't worry too much. Now, of these exponents, we have some specific ones. The first one is square. Not the shape, but a number that is multiplied by itself. Here we have our perfect squares and their roots. Now, you do not need to write this down, okay? I do have a couple examples, like this. 1 to the second power, okay? 1 squared is 1 times 1. 2 squared, again, we're squaring the numbers. 2 squared, 2 times 2 equals 4. 3 squared, 3 times 3 equals 9. 4 squared, 4 times 4 equals 16. And 5 squared, 5 times 5 equals 25. Again, when we square a number, we're simply multiplying it by itself once, okay? Unlike our exponents where the numbers can be different. Now, if we reverse a squared number, we're talking about a square root. And this is a number which multiplied by itself gives the original value. So just think about all of this in reverse, going backwards, okay? The square root of 1 is 1. Okay, 1 times 1 equals 1. Square root of 4 is 2. 2 times 2 equals 4. Square root of 9 is 3. 3 times 3 equals 9. 16, square root is 4. And the square root of 25 is 5. Same process as last time. What numbers will multiply by themselves to give us this information? Okay? Again, just write those examples down. I'm sure you've seen these in the past. I just want to make sure we understand and know them fully. Another specific one here is cubed, all right, or cube a number. Again, not a shape, but a number that is multiplied by itself 3 times. So like this, 2 cubed, or 2 to the third power. This breaks down as 2 times 2 times 2, which equals 8. 3 cubed, 3 to the third power. What's this? Well, it's 3 times 3 times 3, which equals 27. Now, again, I'm sorry if I'm moving too quickly. You can pause these and or go back if need be. Now, in reverse, just like our square root, we have a cube root. A cube root is a number x, is a number y, such that y3 equals x. Now, you're probably saying, what does this mean? Well, just again, think of it in reverse, okay? So we've got the cube root of 8. So how can we break this down evenly into 3 parts? Essentially, that's what it's asking us to do. Well, again, we got to think about the numbers that go into it. And we know that 8 divided by 2 equals 4, and 4 divided by 2 equals 2. So the cube root is 2, because, like last time, we know that 2 times 2 times 2 equals 8. What about the cube root of 27? All right. Again, we're working backwards. Well, 27 divided by 3 equals 9. 9 divided by 3 equals 3. The cube root is 3, because 3 times 3 times 3 equals 27. Now, a couple other things that we want to keep in mind that will be important this term and next term, and will provide us quite a bit of information when it comes to measuring angles. And that is parallel lines. Parallel lines are lines that never meet. So like this, 2 lines will go alongside of each other forever and ever and ever, and they will never cross. They will never meet. The opposite, or the corresponding set, is perpendicular lines. Perpendicular lines are two lines that intersect at a 90 degree angle, excuse me. So like this, okay? And again, this is going to tell us some important information. All right, first of all, we know it's a 90-degree angle, and then we are able to use that information to figure out other angles if need be. Excuse me. A couple more, and I know you've probably seen this before, but I just want to make sure we know it in English and have it resting in our minds, okay? The x-axis. The x-axis is the horizontal axis on a graph. This is the axis or the line that goes left to right. It goes horizontally. On the flip side, we have the y-axis. The y-axis is the vertical axis on a graph. It's going up and down. So we're going to have to know this for this term because we will be learning about translations and transformations. Essentially moving an object or a point around a graph like this. And we're going to have to consider where the x-axis and the y-axis are. Okay, so the next piece is about numbers, okay? And you're probably thinking, Mr. Fitri, I know numbers. What are you doing? I learned this in Pratom. Well, we've got some specific numbers I'd like you to know. Different, shall we say, categories of numbers. First of all, we have an integer. An integer is any whole number with no fractional part. An integer can be 0, it can be negative, and it can be positive. The important thing is that it's a whole solid number, okay? There's no decimal points, there's no fractions. Essentially there's no pieces of the number. It's just a solid whole number. Examples like 0, 4, -8, or 53. Now, not to be confused with what I was just saying, but we have whole numbers. Okay, this is a title. The other one I was talking about was a complete number. A whole number is 0 and positive numbers. Okay, so examples like 0, 9, 25, 64. Okay, the whole number has to be positive. Now, thinking about the positive component of that, a positive number is any number, fraction, or decimal greater than 0. So again, this does not have to be a whole number. This can be a fraction, like it says. So we can include numbers like 23.5, 6, or 2/5. A negative number, on the flip side here, can be any number, fraction, or decimal less than 0. So, using those examples from the last slide, we've got numbers like -23.5, negative 6, negative 2/5. Couple last ones, ladies. All right, an even number. An even number is any integer that can be evenly divisible by 2. And we consider 0 to be an even number. So things like 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, da 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 da. You know this, I'm sure, okay? All of these numbers can be divided by 2 evenly. All right, think about 10. 10 divided by 2 is 5. 6 divided by 2 is 3, etc. An odd number, okay, is any integer that is not evenly divisible by 2. So numbers like 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, etc., etc., etc. Of course, you can divide these by 2, but they're not going to be even. Like 5. If you take 5 divided by 2, it's 2.5. Not a whole number. If you take 11 divided by 2, it's 5.5. Not going to work. Okay? That's why it's an odd number. All right, ladies, 2 remaining slides, and then we'll finish up. The last piece is about, or second to last piece, is fractions. A fraction is a numerical quantity that is not a whole number. So it's essentially a number that is not a whole number. It's a piece of the whole. If you buy a pizza and the pizza has 10 slices or 10 pieces and you eat 3, all right, you've got 7 out of 10 left. You've got a fraction there, 7 over 10. All right, let's look at a couple examples. 1 over 2, a half. Please keep these in mind, all right? These will be much easier to use than saying 1 over 2 or 1 over 4. Let's think about how we can describe this in English terms. So 1 over 2 is a half. 1 over 3 is a third, all right? 1/3. 1 over 4 is a fourth. All right, a fourth. And 1 over 5 is a fifth. So these will probably be more prevalent in your math or science classes going forward. So try to keep those in mind, all right? What's a half? What's a third? What's a fourth? What's a fifth? Now, the other thing is, we are able to simplify fractions, and this is really important, okay? So we simplify them by finding essentially a smaller number out of them. So if we look at 5 over 10, how could we simplify that? Well, 1/2, right? 5 out of 10 is a half. So we can simplify that by saying 1 over 2, a half. What about 4 over 12? A third, right? 1/3. 20 over 100 is 1/5. I'm sorry, I didn't change that slide. Oh my goodness. 20 over 100 is 1/5, not 2/5. Okay? I apologize for that. We're not all perfect. We have to accept our mistakes from time to time. Last one, 75 over 100, 3/4. So we have to think about this by simplifying if we can, all right? We don't need to say 75 over 100 when we can say 3/4. We don't need to say 4 over 12 when we can say 1/3. Make it simple on yourself. Last one is another way of describing a fraction of a number, a piece of a number. And this is a decimal. A decimal is a fraction whose denominator is a power of 10 and whole number is expressed by figures placed to the right of a decimal point. Like this. All right, we've got that little dot there, all right, the decimal. To the right, we have tenths. Okay, each of those numbers represents one piece out of 10. If we move one more space to the right, we've got hundredths, and that represents 1 out of 100 pieces. Okay. So I want us to think about something like this. All right, 10.5 is just 10 and 5 over 10. All right, 10 and a half. .4. This is just 2 and 4/10. All right, 4 pieces out of 10. With that whole number being 2. 20.7. All right, 20 and 7/10. All right, these all represent smaller pieces of the whole. So, ladies, I know this is not ideal. This is not how I would like to introduce these math vocab words. I would prefer if we could be live and talking and figuring these out ourselves. But it is what it is. So please make sure you have copied all of the information on your worksheet. Please continue to do all the e-learning homework because we mustn't fall behind. It's really important we don't miss anything on e-learning. All right, next math class we will continue with some vocabulary words. We have quite a few more to go. All right, thanks so much. Have a good day.